So in this case we have an inclined plane. So if I just draw the inclined plane, so the inclined plane is this. So here, okay, the angle that we have is 40°. Okay, the object that we have, this is the object, they're calling it P, and the object has a mass of 2.7 kg. So that means, so this is going to be 2.7 g Newton. G is gravity, 9.8 meter per second squared. That is the formula for weight. So now we have the reaction force. We know reaction is perpendicular to the surface. So if this is reaction force R, now before even reading the question, let me break it down into components. So this is normal to the plane. So this is going to be mg. So let me write mg as 2.7 g. So this is going to be 2.7 g cos 40. Now this is going to be along the plane. So this is 2.7 g sine 40. Okay, done. Now they are having a particular force. This is not horizontal. It looks horizontal, but it is 10° more. This is 50°. So this is a horizontal force. So let me give this force over here. So this force is 15 Newton, and it makes an angle over here of 50 degrees. So if we break this down, so then it's going to be one is normal to the plane. So normal to the plane is this, and another is along the plane. So along the plane, how do I draw this? Okay, along the plane is this. Okay, so if this is 50, then this angle is also going to be 50 by alternate angle. So this is going to be 15 cos 50° because it's along the plane and the angle is here, and this is going to be 50 sine 50°. So we have broken down every single thing. Now let's check whether this has a rough surface or not. So on a rough surface, so if this is a rough surface, now we need to know whether it is about to go down or about to go up. So the particle is in equilibrium and it is on the point of sliding down. So if it is on the point of sliding down, that means we can consider friction in the opposite direction to motion. So this is mu r. So this is mu r. So mu is the coefficient of friction and r is the normal reaction. Okay, so now when we have drawn this, so this is question number A. So first we have to find the value of r. We have to find the value of r. So as you know, we can take normal to the plane. So normal to the plane. So we know we have r, and there is no other force that is upward. Every other force is downward. There are two other components. One is 2.7 g cos 40, which is this force going down, plus another force going normal to the plane is 15 sine 50. It is 15 sine 50. So this calculation is going to give the value of r. So this is going to be 31.8 Newton. So it's a good idea to write down the answer to two significant figures. So the answer would be 32 Newton. So question number B. So in question number B, we have to find mu. So that means we have to do this along the plane. So along the plane. So we know, so going upward, we have two forces. One is mu r, plus the other force is right over here. This is 15 cos 50. So 15 cos 50, and then we have going downwards along the plane, that is 2.7 g sine 40. So we already know from the previous math what the value of r is. So 2.7 g sine 40 minus, if you send this to the other side, 15 cos 50. So therefore mu equals to 2.7 g sine 40 minus 15 cos 50 divided by r. So I'm putting the value of r a little bit more accurate, 31.8, and this turns out to be, so to two significant figure, the coefficient of friction would be 0.23. That's the value of mu. So this was question number B. In question number C, it says we have a situation where the math is completely changed. So in this situation, the 15 Newton force is removed. We now have to see whether P is going to be in equilibrium, meaning whether mu r is going to hold or not. So let's see what happens in that situation. So in this particular situation, question number C. So here what we have, so we have inclined plane and this is 40°. So this is 2.7 g Newton. So if you take normal to the plane and if you take along the plane, so this is going to be 2.7 g cos 40. This would be 2.7 g sine 40. Now this is normal to the plane reaction force, and now this is mu r. So one thing is very, very important. The mu value is the quality of the surface. So the mu value is always constant regardless of whether the situation of the math has changed. For example, here the force is removed, but that will never affect mu. So mu is going to be 0.232 r. However, the value of r will now change because there will be more force that it needs to hold, because previously there was another force that was balancing the situation. Now we have that force is less, so that situation has changed. So we have to check in this particular math whether these two are going to hold. If the friction is more than this, that means it will be in place. If the friction is equal to this, then it is going to be in place. But if this is more, then this is not going to be in place. So first of all, let's do along the plane. So along the plane, let's check the value of, actually let's not do along the plane, let's do separately along the plane. So let's do friction separately. So friction is 0.232 r, and then the downward force, it is 2.7 g sine 40. We need to find the value of r. So let's do normal to the plane. So normal to the plane is always in equilibrium. So normal to the plane is r equals to 2.7 g cos 40. So we have calculated the downward force. So 2.7 g sine 40, it is 17.01 Newton. And then we calculated the reaction force, which is 20.27. So then we plugged in the value of r over here, and we found friction to be 4.7. So we can see that the friction is quite less than the downward force. So downward force is greater. So since the downward force is greater than the maximum friction, this is actually mu r is maximum friction. So the object will move